Our fourth target for our chemical bonding unit is analyzing and interpreting covalent compounds. And a covalent bond is the force of attraction that creates a chemical bond between two nonmetals. So if I'm forming a covalent bond between two nonmetals, it's because electrons are being shared between atoms. And covalent compounds usually are created between two nonmetals since they are looking for just a few more electrons and want to hold on tight to the ones they already have. Typically, covalent compounds usually are liquids or gases at room temperature. So for example, H2O, water at room temperature, is a liquid. We have two nonmetals bonded to each other. Or even O2, or breathable oxygen, is a gas, and it's two nonmetals bonded together. Covalent compounds usually have low melting and boiling points. If you think about it in terms of water, water's melting point is 0 degrees Celsius and boiling point is at 100 degrees Celsius, which is fairly low compared to other compounds. Now, covalent compounds and some ionic compounds can have single, double, or triple bonds depending on how many valence electrons atoms can share with each other. It's important to remember that single bonds are the weakest. At this point, we're also going to teach you how to diagram the electron sharing between two atoms. So if I have H2 as a compound, one hydrogen has one valence electron, so the other hydrogen has one valence electron. If these electrons are being shared, because they're both nonmetals, we're just going to draw a circle around these two electrons to show that they are sharing in between those two atoms. The same thing goes for oxygen. So one oxygen atom has 6 valence electrons. And the other oxygen atom would also have 6 valence electrons. So what's going to happen is that these guys are going to be shared, and then these guys are going to be shared between the two atoms, which means we're going to have a double bond between both oxygen atoms. N2, our last example, has 5 valence electrons. So because these guys are already paired up, we're going to leave them alone, and these guys will be shared in between the two atoms. This pair will be shared, and then the last pair will also be shared. So we have 3 pairs of shared electrons. So this would be a triple bond. So this nitrogen molecule has a stronger bond than this hydrogen molecule because this is a triple bond, and hydrogen can only have a single bond. Naming covalent compounds is a little more complex than naming ionic compounds. So this is where prefixes come into play. And we have 10 prefixes: 1 mono, 2 di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. So the first rule is to determine the amount of the first element. So if I look at CO2, I only have 1 C. Then it says find the appropriate prefix, then write the full name of the first element. Then there's a special note here. It says if there is only one of the first element, just like in our first example, we do not need a prefix because it's considered redundant or repetitive. So for this first example, I only have 1 C, and I don't need a prefix, so I just have one of the first one. So I'm just going to write carbon. The second rule says determine the amount of the second element, and then find the appropriate prefix, and then write the second element's name, and we forgot to mention, with an IDE ending. So I have O2, so I have 2 oxygens. If I look at my prefix chart, 2 is going to be di, so I'm going to start off with my prefix, and then oxygen with an IDE ending is oxide. So CO2 is carbon dioxide. If I do ClO next, Cl, I only have one of them, but it's the first element, so I don't need a prefix. So I'll just write the full name of the first element. And then I have O, and I only have one of them. But because it's the second element, now I need to use the mono prefix. So it'll be chlorine, mono, or monoxide. The last example is N2O5. So if I have two nitrogens, so it's the first element, but I have more than one. So now I need a prefix. So I look at my prefix chart. 2 means di. So di, then the first full name, so nitrogen. And then O5. So 5 prefix is penta. So it'll be pentoxide. Pause the video and try these 6 examples on your own. Then press play to see if you were correct. So CCl4 would be carbon tetrachloride. N2O would be dinitrogen monoxide. PBr3 would be phosphorus tribromide. ClS2 would be chlorine disulfide. P2O5 would be diphosphorus pentoxide. And last but not least on this side would be tetraphosphorus decoxide. Now that you know how to name them, writing the covalent chemical formula is actually far simpler. So what we're going to do is we're going to first write the symbol for the first element name. And if it has a prefix, we'll put the number of that prefix as the subscript of the first element. So down here I have carbon tetrachloride. Now the first element is carbon and I don't see any prefix before it. So that means I only have one. So I'm just going to write C, and I don't need a subscript because I only have one of them. The second rule is write the symbol of the second element name, and if it has a prefix, put the number of that prefix as subscript on the second element. So tetrachloride, so looking at this part, chloride is like chlorine, so Cl, and tetra is the prefix for 4, so I put the 4 after the Cl. So CCl4 is the chemical formula for carbon tetrachloride. Dinitrogen, so I'm going to find the element name, which is nitrogen, and that symbol is N. And then I have Di, or di, that means 2, so I'll put a 2 after the N. The second element says pentoxide, so oxide is the ending form of oxygen. And then pent means 5, so it's N2O5. Pause the video and try these 7 examples on your own, and then press play to see if you're correct. Carbon disulfide would be CS2, dinitrogen would be N2, and then tetrahydride would be H4, carbon tetrachloride, CCl4, diphosphorus would be P2, while trioxide would be O3. Tetraiodine is I4, non-oxide would be O9. Disulfur is S2, while trioxide is O3. And last but not least, dinitrogen is N2, while tetroxide is O4.